Hi, my name's Alan Smith, and in this webcast I'll be demoing the Cosmos DB AutoScale functionality and seeing how it can react to varying loads with a real-time data stream from Twitter. With some services, like Azure Storage, you pay on a per transaction basis. So if you've got a variable load, you're going to be paying for the area under that load curve. However, with Cosmos DB, you pay for the capacity of the service. And that means you're going to be paying for the area under the green graph. And in this scenario, you're going to be paying for a lot of capacity that most of the time you're not utilizing. So when considering setting the capacity for a service to handle this load, you could pay a lot of money to ensure that the capacity is always going to be above the peaks. If you try to save money by provisioning less capacity, there's going to be lots of scenarios when your application can't handle the load. So you may choose a compromise. Pay a reasonable price for the service, but accept that there's going to be some times that your service has performance problems handling the load. However, with AutoScaling, we're able to provision a service that can adjust its capacity and therefore adjust the billing based on the load on the service. So let's explore how we can do this using the AutoScale functionality in Cosmos DB. For the demo, I'm using a console application. And this application uses a tweet-in-if-you-NuGet package to retrieve and process a stream of tweets, matching a specific search criteria. The Microsoft Build conference is taking place as I'm recording this, so I'm using the MS Build hashtag as a filter criteria. Before I store the tweets in Cosmos DB, I'm anonymizing some of the user details. And to calculate the end-to-end latency from my application, I'm using a stopwatch to record the time that it takes to write each tweet to the database. And every 10 calls, I'm going to display the average latency. So let's create a database and a container to store these tweets. I'll create a database called Twitter. And initially, I'm going to use the manual scaling and use 400 RUs, which is the cheapest option, and will cost a little over $23 a month. I'll generate a container called tweets, and I'm going to partition based on the string value of the user ID who tweeted the tweet, which should be a fairly good partitioning strategy in this scenario. So let's create that container. And now that's done, I can start my application. So in the Data Explorer, we can browse to the tweets container and the items. And we can see that we've got 3 tweets from the MS Build tweet feed. We can see that the tweets are actually JSON documents, which makes Cosmos DB a great choice for storing this data. In the Azure portal, I'm going to browse to the metrics of the Cosmos DB account. I'm going to open a new tab, go to Monitoring, select the CosmoDoc account, and I'm going to monitor the total requests and set the time period to the last hour. And you can see that we've made some requests to the database. And the average write latency for each tweet was between 12 and 17 milliseconds. I'm going to leave this running for a while to let some data build up in the graphs. So after a few minutes, we can see there's between 2 and 10 requests per minute running against the database. And we can see the same type of statistics in Azure Monitoring. And we can see that the average write latency is between 12 and 15 milliseconds. The MS Build tag isn't really generating that much load on the database. So I'm going to change the search criteria to the word "the." And this should generate a much higher volume of tweets to process in the stream. So we can see immediately that we're getting a much faster stream of tweets coming in. We can also see that the latency of these write operations has been severely impacted. Instead of being between 12 and 15 milliseconds, it's now between 120 and 240 milliseconds. So this additional load is really impacting our performance. We can see in monitoring that we've got a huge increase in the number of total requests. And in this monitoring graph, I'll add a metric for the percentage of the RUs that we're consuming. We can see previously it was between 18 and 28%. But with the increased load, we're now consuming 100% of the RUs in this database. I'll pause the recording and let some data build up in the graphs. So we've been running for quite a few minutes here. We can see that the number of requests is fairly stable, but all this time we've been consuming 100% of the RUs on this database. And the query latency looks to be between 140 and 230 milliseconds. In the metrics view, we can see that we're getting a little over 300 requests per minute running against a tweets container. However, we can also see that we're getting over 200 requests per minute that are exceeding the capacity for the database. So let's try scaling the database. I'll open a new tab, go to the scale configuration of the Twitter database, and I'll scale from 400 to 1000 RUs, and click on Save. So 1000 RUs is costing us $58 a month. We can see immediately that this has had a big improvement on the latency. We're down to around between 50 and 80 milliseconds for these write operations. So let's scale to 4000 RUs. And immediately, we've dropped to around 15 milliseconds of latency per call. Let's try 10,000. And I'll leave this to run a few minutes to let some data build up in the graphs. So after a few minutes, you can see that the percentage RU consumption has decreased to around 50%. So if we scale the database to around 6000 RUs, we should be able to process the load and be within capacity. 6000 seems to be a good setting. We're able to process the load, and we're using about 70% of the RUs in the database. So if we've got any spikes in the load, we should be able to handle those. So I'm going to simulate a drop in load by going back to the console and changing the search filter back to the MS build hashtag. I'll run this and pause the recording for a few minutes to allow the graphs to settle. So after a few minutes, you can see that the load on the database has dropped. But we're still paying for 6000 RUs on this database. So in my scenario, if I'm going to be using different search criteria that's going to generate different load, I want my database to be able to scale, to be able to process that load. So let's go to the Twitter database, into the Scale options, and select AutoScale, and click on Save. So we've now provisioned AutoScaling with a maximum of 6000 RUs, and a minimum of 600 RUs. And it's saying here that the database throughput will automatically scale from 600 RUs to 6000 RUs based on usage. So let's see how this autoscaling can handle the variations in the load. So I'm going to generate another monitoring window, and I'm going to add the metric of provisioned throughput, and I'll set the graph to the last hour. So we can see here when we had initially the 400 request units, and then I manually scaled up to 10,000 request units, and went down to 6,000. Now with autoscaling and a very low load, we can see that the provisioned throughput is now 600 RUs. I'll pause the recording and let some data build up in these graphs. So we can see that the provisioned throughput is stable at 600 RUs. And going back to the load metrics, you can see that we've still got a very low load on the database. So let's change the search filter back to the word "the" and run the application again. You can see it's processing a lot more tweets here, and the latency is where we want it, around about 15 to 18 milliseconds per write operation. I'll leave this running and let some data build up in the graphs. So here we can see that the database has auto-scaled to 4100 RUs, and then scaled down to 3700 RUs. And we can see that this is between 75 and 84% utilisation of the RUs available. Going back to the monitoring tab, we can see that we don't have any requests exceeding the capacity. So in my scenario, with Cosmos DB autoscaling, it's giving me a very cost-effective solution to be able to rapidly scale the capacity of the database when the throughput of my application demands it, and always ensure that I'm making very cost-effective usage of the resources. My name's Alan Smith, and I work as a developer, trainer, mentor and evangelist for Active Solution in Stockholm, Sweden. I'm an Azure MVP, and I speak at many international conferences. I'm also involved in the organisation of the Cloudburst Conference and the AI Burst Conference, hosted in Stockholm. I specialise in delivering classroom and on-site training in the Microsoft Azure and AI technologies. I also deliver remote training and mentoring. I host seminars and workshops for companies. I've authored a number of Pluralsight courses, and I also speak at conferences. If you're interested in any of the above, feel free to contact me on cloudcast.net@gmail.com.